All right, in this problem, we're going to solve x minus 1 over x minus 3 greater than or equal to negative 2 over x. And what we want to do is the same approach we did before, and that is our first thing is we're going to set equation to 0. This is just a much easier place to work from. So I'm going to bring the negative 2 over x to the other side. So this gives me the new problem of x minus 1 over x minus 3. So I would change the sign, so this becomes plus 2 over x greater than or equal to 0. Now we need a common denominator. And so notice this. We're going to have to do a little bit of scratch work here. We're going to need to get this, add these two fractions. So look, if you go through the process, you'll find the lowest common denominator is x times x minus 3. So what we would need to do is the x minus 1 over the x minus 3 is going to need an x over x to be x squared minus x over, and I'm going to leave the denominator factored, x times x minus 3, and then the other fraction, 2 over x, is going to need an x minus 3 over an x minus 3. And remember here, all I'm doing is these are just ones, that's all, just big ones. So we're changing its appearance, not its value. So now I have 2x minus 6 over x times x minus 3. All right, now let's put this back to our original problem. So now I have x squared minus x over x times x minus 3 plus 2x minus 6 over x times x minus 3 greater than or equal to 0. But now that we have a common denominator, we can just add the numerator. So I have like terms. Notice that in here I have a like term, to use a different color. I have a like term here in the x's. Here's a 2x, here's a minus x. So when I write this out, this becomes x squared minus an x minus 6 over x times x minus 3, and we're going to find out when it's greater than or equal to 0. All right, now oh, I'm sorry, it's not minus x, it's a plus x. Good gracious. Okay, then let's see. Now, at this point, you'd want to play the game and factor the numerator. So I'm going to just make that note, and you're good at that by now. So factor the numerator. To solve x squared plus x minus 6 equal to 0. And what you'll find is that you get x plus 3 times x minus 2 equal to 0. So you'll have x equals negative 3 and positive 2. So that's your numerator. And then the denominator, we need to do the same thing. So in the denominator, we're going to solve x minus 3 equals 0. And notice it's actually the same thing. One of your factors is x is 0, or the other one is x minus 3 equals 0. If I add 3 to both sides, x equals 3. Now this one's actually really kind of neat because look at how many pieces are going to go on our line. So when we do this, let's see, I have a 0, put 0 here. I have a negative 3, 1, 2, 3. There's negative 3. We have a 2, 1, 2, and a 3. Oh, both of these are on our number line. All right, I'll put a little extra line here. Then, now let's take a look at what these represented. The problem says, when is this piece, back up here, when is all of this greater than or equal to 0? So in other words, the numerator can be 0. So the solutions that came here when the numerator was 0, those are okay. So we're going to use dots there. Now, so let's put dots there. And I'll get a different color for this. We use light green today. So for negative 3, I get a dot. And at positive 2, I get a dot. Now, my answers of 0 and 3, those are when the denominator is 0. And that can't happen. So those we use circles. Now what we need to do is take a test value from each interval, and then we can write our solutions. So let's try negative 4 here. How about negative 1 in this next interval? Between 0 and 2, let's try 1. Between 2 and 3, we're going to have to just try 2.5, or how about that, or 5 halves. And then above 3, we'll try 4. So we have to try all those values, and we'll try them back in the original equation. So where is that? Right up there, x minus 1 over x minus 3. Okay, here we go. So for negative 4, we're going to take, and you know what, I'm going to do this. Let me erase that for a second. And we're going to go back up here. I'm going to bring that down there so I can remember this. So let's just grab this, and we're going to copy, bring it down here so I can see it. And then let's try our values. So let's see, negative 4. So that's going to be negative 4 minus 1 over negative 4 minus 3. And we want to see if this relationship holds negative 2 over negative 4. So I'm going to come over here. My next step, negative 4 minus 1 is negative 5. Negative 4 minus 3 is negative 7. And we want to see if this is still true. This is a positive 1/2. And one more step is a negative 5 over negative 5 over negative 7. That's really 5/7. And the question is that greater than or equal to 1/2? And the answer is yes, it is. And if you're thinking, really, how do you see that? Because fractions can get a bit difficult. You can always cross multiply. So 5 times 2 is 10. 7 times 1 is 7. Wherever the larger number is the larger fraction. So this first one, this is true. And so we can shade this region. So we're going to just shade all of this region below negative 3. So I'll put an arrow on it. And that's our region that we just found. And now we repeat the process. Negative 1. So we're going to substitute negative 1 minus 1 over negative 1 minus 3 greater than or equal to negative 2 over negative 1. So this becomes a negative 2 over negative 4 and greater than or equal to, this is just a 2. And if we come one more step, what it's saying is, it's a negative 4, is the question is saying, is 1/2 greater than or equal to 2? And the answer is no, false. So we do not shade the region between negative 3 and 0. All right, let's repeat. Now we try this with 1, and we write 1 minus 1 over 1 minus 3. We're going to check to see if it's greater than or equal to what minus 2 over 1. Well, this is just going to give me a 0. It doesn't matter what the denominator, that's just 0. And is 0 greater than or equal to negative 2? And the answer is yes, that's true. So I would shade this next region. Okay, let's keep going. Let's check our next region. This is going to be 2.5. 2.5. So if I go 2.5 minus 1, 2.5 minus 3, greater than or equal to negative 2 over 2.5. Well, let's see. This one looks like it could get a bit messy. This is going to be a negative 0.5 over... Oh, no, I'm sorry. Let me fix that. Okay, my numerator is going to be 1.5. 1.5. My denominator is going to be negative 0.5. And the question is that greater than or equal to negative 2 over 2.5? It's kind of interesting. If we look at the right-hand side, this answer is actually negative 3. So is negative 3 greater than or equal to... So I'm going to do a little bit of arithmetic. Remember that 2.5 is 5 halves. So if I divided, this would be negative 2 divided by 5 halves. That's going to be times 2/5. So really, the question is asking, is negative 3 greater than or equal to negative 4/5? And the answer is no. It's false, so we do not shade that region. Okay, I'm getting kind of tight on space, so we're going to have to go up and down a bit. So I try 4. So 4 minus 1 over 4 minus 3, and we want to see if it's greater than or equal to negative 2 over 4. So that's going to be 3 over 1 greater than or equal to negative 1/2, and that is true. So I would shade this last region out here. There, now that's my graphical solution here. This is a graphical solution. And if I want to write this using interval notation, I'm going to have to go back and forth here. So in solution as interval notation, well, let's go pick up all of our green areas. So we have the first green area here that we see is this one, from negative infinity all the way up to negative 3. So let's record that. So infinities always get parentheses. So we go negative infinity up to negative 3. And notice that negative 3 has a solid dot. So it's got a solid dot here. Oops. It's got the solid... Sorry, my piece just froze up. Okay, so we have our solid dot, and so then what we can do is, let's pause right there. Okay, I'm back. I had some technical difficulties, but what we were doing is writing the interval notation for this graphical solution. Our first interval on the left, and we always read it from left to right, just like you would read a book, starts out at negative infinity and it goes to negative 3. And since we can include the negative 3, we use a bracket. So we write negative 3, we write negative infinity, comma, -3 bracket union. Then our next interval is from 0 to 2. And notice that we can't have 0, but we can have 2. So it's parentheses 0, bracket on 2. Parentheses 0, comma, bracket on 2. And then our last interval up here, our last interval is from 3 to infinity. And we cannot have 3, so we're going to have parentheses on both of our numbers. So we have parentheses 3, infinity, parentheses. And that is how you write the graphical solution in interval notation. And that's how you solve nonlinear inequalities. Thank you for watching.